ANOVA with Kij equal 1. To start things off, what is a two-factor ANOVA? Well, a two-factor ANOVA is used to analyze a relationship between two different independent variables called factors and determine if they have an effect on the outcome. Each factor has its own levels. I is used to represent the level of factor A, and J represents the level of factor B. Here, there is an example of what a data table and experiment looks like and the chart demonstrating how to identify observation. Now we're going to go ahead and take a look at Fick's effects model, which only looks at the levels that are actually represented in the experiment. It defines a true average response of one factor A, which is level I, and factor B, which is level J. Now moving towards the additive model. The additive model is an extension of the Fick's effects model. Additive meaning that the difference and mean response for two levels of one factor is the same for the levels of all the other factors. Included are two examples of additive and non-additive models. Hypothesis testing. There are two different hypotheses, one for each factor. The null hypothesis states that the factor has no effect on the true average response, while the alternative hypothesis states that the factor does indeed affect the true average response. Only one level of a factor has to differ to reject the null hypothesis. You also must calculate a test statistic for each factor to determine whether or not to reject the null hypothesis. Here I have included some of the formulas which are required for hypothesis testing, including the equation for the sum of squares, fundamental identities, mean squares, and test statistics. Given from this hypothetical example, A, B, C are machine lubricant types, while 50 and so on are the actual amount being applied to the machine. Using Excel, we are able to calculate the test statistics a lot more efficiently, as you can see, giving us the mean squares, sum of squares, and so on. Two-factor ANOVA is used in many engineering scenarios. An important application is materials testing, which is an example that I provided previously. It allows engineers to see what factors will affect the durability and strength of their products during material testing. Some examples of this are testing the safety of vehicles, the cracking of concrete, and the strength of steel. It is also a useful tool to determine how different chemicals and materials affect each other, providing very valuable information to any sort of engineer.